Alright guys, so my goal today is to finish Ellipse day 1 and day 2. We're kind of almost to day 2, believe it or not. And that will give you lots of time to ask homework questions tomorrow and have essentially like a work day. But I want homework questions. You do? Can you save them for tomorrow though? Perfect. Alright. Girl. What? Different ellipses. Yes. We're going to skip number 3 for the sake of time and space. Let's look at number 4. So you should have your bright pink formula card out next to you as we do these questions. And I'm going to be graphing and I'm going to be finding all the good things that they want me to find. Like they're going to want me to find my vertices. They're going to want me to find my co-vertices. And they're going to want me to find the foci. But first, I think a great way to start all of these conic questions is to identify the center. So, this is actually where kids screw up, so be careful. Where is the center?
-3, 2.
That is what kids do to screw up. Yes, that's a good demonstration. The center is always at h, k. So this is always h because it's with the horizontal movement. An ordered pair is always x, y. Now, commutative property, Daniel, can't you flip them around? Like there's no like set in stone, this comes first. Like I could have written x minus 2 squared over 25 plus. Yeah, so, no, 2, -3, 2, -3. All right, so for me, I usually go straight to my graph because I struggle with formula usage. This is worksheet 5B. But if you guys don't want to go straight to the graph, that's fine too. But can you tell me whether we are looking at a horizontal or vertical ellipse based on which one's going to have a larger axis? So this is larger, right? And it's underneath the y-coordinate, so that means we're going to have a vertical ellipse. So when you're, oops, that's too many eyes. So when you are looking at your formula, make sure you're looking at the vertical ellipse formulas. The other thing I might do right now is kind of jot down who A and B are. So A is the square root of this number, so A is 8. And this number is B squared, so that means B is 5. And I kind of learned my lesson yesterday. I might as well just go hurry up and calculate C while I'm at it. There's a formula that they gave you on your formula card for C. It's the square root of A squared minus B squared. Typically this number comes out irrational. Not always, but typically. So what is the square root of 64 minus 25? Is that 39? Square root of 39? Which is about, I heard 6.2 last hour, if I type that on my calculator. Okay? So all of these things are going to be used to find vertices, co-vertices, and foci. So if you are really good at formula usage and you're really good at identifying it, then maybe that's where you start. So on a vertical ellipse, the vertices are found at h, k plus and minus a. So for me, because I'm old school and wasn't given too many formulas apparently, but also because I mess up formulas so much, I just start conceptualizing what we're doing here. A vertical ellipse, the major axis would move vertically, right? Up and down. So that's why you're adding the a to the k value instead of the h value. So let's take this further. The h value is 2. K is -3. And then we're going to add and subtract the value of a, which we found to be 8. Now PreCalc, you got to do better than this. You got to actually give me the 2 ordered pairs. So this is 2, -11 is one of them. And then 2, 5 would be the other one. Now, you might notice over here they're counting by 2s. So that's really annoying. When I come back to graph it, I'm going to show you like how you can graph it without having these ordered pairs. And I think that's actually a better way to do it, but we'll come back to that. All right, your co-vertices. On a vertical ellipse, co-vertices are in the horizontal direction. It's the smaller axis. So that would make sense if the formula takes your h and adds a b to it, or subtracts a b. So h plus and minus b, k. So for us, that would be 2 plus and minus 5, -3. And then again, PreCalc, I would argue you're better than this. You can give me the 2 ordered pairs. So 2 minus 5 is -3, -3. And then 2 plus 5 would be 7, -3. And then while we're at it, let's go ahead and figure out foci. Foci would be along the longer or the major axis. So for a vertical ellipse, it would make sense to add and subtract a number to k. So k plus and minus c this time. So for us, that would be 2 comma negative 3 plus and minus the square root of 39. Now, I'm a little lazy. I'm not going to necessarily make you split this one into 2 different ordered pairs because they're irrational and incredibly funky. So you could give me like estimations if you wanted to, because we said this was like 6.2, right? So you could be like 2 comma and then whatever negative 3 plus 6.2 is and vice versa. But either way, here's what I'm going to show you. I'm glad you found all these ordered pairs because it is something I'm going to check on the test and on your homework. But what I really want to see next is your picture. So for me, I plot the center. Now remember, this is all counting by 2's because they're trying to save you space. So 2, negative 3 would be right here. And then in the y direction, it's telling me to move 8 units. So from the center, I'm going to move vertically 8 units in both directions. So 2, 4, 6, 8, and 2, 4, 6, 8. I can't really tell right now, but we were supposed to make a point at 2 comma negative 11 and 2 comma 5. Did I do that?
Yeah.
Nailed it. All right, so horizontally in the minor axis, I'm supposed to move 5 units in each direction. So 2, 4, 5, and 2, 4, 5. And again, I was supposed to plot at negative 3, and 7, negative 3. Does it feel like I did that? Yeah. Cool. And now I'm going to ruin it all by trying to draw an ellipse. All right, here it goes.
So good.
You
Jinxed.
Oh, it's not bad. It's not bad.
It got a little weird here.
just help
Still
us
not
make
bad.
them look prettier. Will you accept a diamond?
No.
At least got a
No.
little curve in there.
No, man. Round it out. Round it out. Like more Easter egg, if anything. I'm going to draw a baguette later on today. Yeah, we have a very baguette-looking ellipse coming your way. Yes. And then when you draw the foci points on it, it looks like a baguette. It looks like a Panera baguette. All right. Anyways, I give up, guys. These are not going to get better. I've been drawing these for, oh my God, like over 20 years now. Yeah. Yep, just did that math. They're not getting better. Okay, this is it. This is as good as they're going to get. All right, so we're still on worksheet 5B. And this one's already done for you, so without looking at your paper, just watch up on the board. What we're about to do is take a general conic form ellipse and complete the square like we did with the circles and come up with the standard form of the ellipse. This gets a little complicated though. All right, let me show you. So for the x's, I'm seeing 4x squared plus 24x. Well, one of the rules for completing the square is you cannot complete the square unless your quadratic term has a coefficient of 1. And it wouldn't help us to divide everything by a 4 because that would make this coefficient a 9/4, which is definitely not a 1 and nothing I can get rid of. So instead of dividing by a 4, what we're going to do is factor out the 4. And then we're going to proceed and try to complete the square on the x's. So this becomes x squared plus 6x plus a blank, like always. And we're going to do the same thing with the y's. But again, I noticed the y doesn't have a coefficient of 1 here, so we got to factor out the 9. And you got a y squared. Remember, you factored out a 9, so minus 4y plus a blank, like always. This constant is just kind of in the way. He's going to have to move over to the other side, so I'm going to subtract the 36 over. And then, like always, I got to balance out my equation. So I'm going to add something from the blue, and I'm going to add something from the red. So when it comes to completing the square, this doesn't change. You still take half of this term and you square it. So half of 6 squared would be a 9. But what really is this 9? Because it's not a 9. It is a 36. See it? So over here, I got to write a 36. That's what balances out the equation. Okay? This, the blank, is going to be half of this squared, so negative 2 squared is 4. But this 4 is really a 36. It's kind of coincidental. There's a bunch of 36s in here. The equal sign on the right side says equals 36. Yes, I agree with you. Okay, so the 4 I'm going to leave in front. Now I can write this quadratic in its factored form from completing the square. And then same thing on the y's. Leave the 9 in front, and you got a y minus 2 squared. Clean this side up, and you got it equals 36. Now think about what our ellipse formula has looked like. It always says equals 1 on the end. So you got to get that in order to have standard form. So this would have to be divided by 36. And you can do that as long as you divide everything by a 36. And this is where the denominators come into play. So look at this fraction right here, this coefficient. You got a 4 over 36, better known as a 1/9, right? That's a 1/9. So the way we'd write that is we wouldn't write the 1 because that's just silly. And we would just say over 9. And then right here, this fraction coefficient is really a 1/4 when you reduce it. So we wouldn't write the 1, but we would say over 4. And then 36 divided by 36 is a 1. Ta-da! There is your standard form of an ellipse. And then we could go and find everything. What's your center? What's A? What's B? What's the foci? What's the vertices, the co-vertices, and graph it and find eccentricity today too. That is going to be a good time, guys. You excited? I know you are. All right, let's try one together. Number 5. Now, we're going to not do anything else on this worksheet except for number 5 because yeah, you can all use the whole space for a room, and you're probably going to want it like horizontally. You're going to need a lot of room. Normally we would have taught this lesson after we taught the parabolas lesson, because my next question would be, you know, based on the way your equation looks, what kind of a conic do you have? Eventually, when we learn all 4 of them, we will ask you that question. You know, do you have a hyperbola, an ellipse, a circle, a parabola? This one, spoiler alert, it's an ellipse. So it doesn't matter whether you complete the square on x's or y's first, because at the end of the problem, if you're not happy with the order, you can just move the terms around because it's an addition problem. So I'm going to complete the square with the y's first, and what's kind of nice is I notice it does have a coefficient of 1. So I don't have to do any factoring out in this case. However, I totally have to factor out something on the x's. I cannot complete the square unless I take the 6 out of the problem, so factor out a 6. And then you're going to be left with x squared minus 4x plus blank. Someone already moved the 5 over. That was nice. And then you got a blue blank, and then you got to balance out with the red as well. All right, speaking of the blue blank, what number should I put in the blue blank if I take half of this and I square it? It's a 1. Very good. Now, in this first red blank, half of -4 squared would be a positive 4. But what really is this number? It's really 24. So this quadratic gets rewritten in its factored form, y plus 1 squared. Leave the 6 in front for now. And then this quadratic, we're going to write in his factored form, which is x minus 2 squared. And then I just need a little adding help here. 5, 1, 24, better known as 30. So one more step, and then we are in standard form of an ellipse. This number on the end has to say 1, so I'm going to come back through and I'm going to divide every single term by a 30, including this guy. So this first fraction has a 1 over 30 coefficient, so I'm just going to call it y plus 1 squared over 30. That's a gross number. All right, plus, now this coefficient becomes a 1/5. So we're going to write that as x minus 2 squared over 5. And then 30 over 30 is a 1. Thank goodness they don't want me to do more work on that one, guys. Because what's your a value? Square root of 30? Gross. And then what's your b value? Square root of 5? Also gross. No thank you. Move on. Alright, find the next page, please. So y'all could please look at, yeah, page 6. You got it. I gotta find, there we go. That's what I want. So we're going to do number 1 and we're going to skip number 2. On number 1, guys, we're going to find everything. Actually, yeah, that's fine. We can do number 1. They're both equally exciting. Let's put it that way. We're going to complete the square. And then we're going to find vertices, co-vertices, foci. We're also going to graph it. You know, do you care if we do 1 or 2? No. We have to do one of them. 2's horizontal and, no, 2's horizontal and, no. 1 is horizontal and 2 is vertical. Did you catch me in my dyslexia warp there? Ah. Just you feel bad for me, okay.
It looks like number 2 is easy.
Does it?
Yeah.
Okay, let's do 2.
Almost everything is divisible by 25, or by 5.
The word almost is very telling right there, though, huh?
Besides that ugly 9.
Yeah, 9 and 25, no thanks. All right, so we do need to complete the square on the x's. I'm going to do them first just because they're simply there. So let's factor out the 25. Now you do need to write kind of small here, or you can use the space from number 1 to do all your work here. Yeah, this is not as pretty as you thought, huh?
Yep.
Good news, 1 wasn't any better. So this is x squared. This becomes a minus 2x plus 1, or plus blank. Sorry, jumping the gun there. And then for the y's, we're going to have a 9 we need to factor out. So then that becomes a y squared minus 10y plus blank. Now we're going to have to move that 25 over by subtracting it. And then I'm going to have a lot of balancing I need to do here, so I'm going to add something for the blue and for the red to balance it out. Okay, let's talk about this blue blank. I already spilled the beans and told you it was a 1, but is it really a 1? It's really a 25, so put a 25 over here. And then this red blank, half of negative 10 squared is a 25.
Whoa, whoa, whoa.
225? Because 9 times 25 is 225. Fingers crossed on that one, yeah? Okay. Wait, yeah, okay. So, for the blue part, leave the 25 as a coefficient. Write the x squared minus 2x minus 1 as x minus 1 squared. For the red part, leave the 9 as a coefficient, but then write the y squared minus 10y plus 25 as a y minus 5 squared. And then you got 225 over here. So now I got to remember ellipses have to say equals 1 to be considered in standard form. So I'm going to have to divide by 225 here and here and here. And this isn't as awful as it looks. This coefficient, 25 over 225, is a 1/9. Right? If I reduce that? Okay. So this is x minus 1 squared over a 9. Plus this guy, the 9 over 225, is a 1 over 25 when you reduce it. Are we all okay where those denominators are coming from? Okay. And then equals 1. So good news, good news. You have the formula. Even better news, now you get to use it. Okay, so this is a case of kids get really stuck with the formula and they're like, well, the x is first, so this is going to be a horizontal ellipse. Tell me if that's true.
That's false.
That is false, because the commutative property states that you can flip this around if it bothers you, but this is the larger axis. So your A value is actually on the vertical axis, and it's a 5. Your B value, which is the smaller guy, would be a 3. And you know what? While we're at it, can you hurry up and just go find the center too, but let's find C. So C, which we're going to need for the foci in a minute, would be square root of a squared minus b squared. And this is one of the rare cases where it comes out kind of pretty. You got the square root of 16, which is 4. All right, before I get too deep into the formulas, guys, can you tell me where the center is located? Daniel?
The center is located at
He's second-guessing himself so much.
1.15.
1, 5, thank you. Always x first. 1, 5. All right. So, depending on whether you feel like you're a formula person or a conceptual drawer, you want to go to the picture? Okay. So, center at 1, 5. So, 1, and then 1, 2, 3, 4, 5. Boom, there's your center. So, along your major axis, which is on the vertical part, we're going to move 5 units up and 5 units down. So, the A is 5. Okay, apparently we're going off the grid. Cool. That made me nervous for a minute, but I double-checked the key. Looks like we're doing well. Now, on the minor axis, we're supposed to move horizontally this time, unit 3, in both directions. But now I'm going to draw through my work. All right, here it goes. So ugly. Very Easter eggy. Ah. It's like a Reese's peanut butter Easter egg that got left out in the sun.
Oh, I love
Aren't those wonderful?
Those are the best.
Oh, maybe.
My mom bought some of those.
1, 2. I sure did.
It's okay, just keep it.
Just keep it. No, I can't. It'll really add to this picture if I fix it. 1, 2, 3. It's supposed to be right there, huh? Did I go enough?
Now
1, 2, 3.
Perfect.
Now it's going to be even better.
Ah, yes.
Yeah, that really fixed it.
Looks like a pear.
Oh, well.
That's pretty good. If
This side got real weird. This side, I finished strong, man. I think.
That's way better than I did.
Okay. Well, now remember the value for C was the distance to the foci. So from the center, you can, this is a nice number. So 1, 2, 3, 4. And down 1, 2, 3, 4 along the major axis. Cool beans. So if you could figure out where you plotted everything, assuming you plotted correctly, you can actually just give me all those points. But let's talk about how the formulas work. So this being a vertical ellipse means that when my teacher asked me for the vertices, she's asking you to look at the formula h, comma, k plus and minus a. So for our information, what does that look like? That looks like 1, comma, 5 plus and minus 5. And then again, pre-calc, I would argue you're better than this. Give me the 2 points. So you got 1, comma 0 and 1, comma 10. Which is totally where I plotted them. Clearly, you can see that. All right, so the co-vertices. On a vertical ellipse like this, the formula adds to the horizontal piece this time with the smaller b value. So h plus and minus b, comma k. So for our formula, that would be, thank ya. And this is where, thank goodness, Taylor fixed me, but maybe I would have noticed that I did something goofy at this point when I originally plotted wrong. 1 plus and minus 3, comma, what was k? 5? All right, so the 2 ordered pairs are, they were supposed to be at -2, 5, which is originally, I screwed up. And then 4, comma 5. Cool beans. And then we already know where the foci are, but you know what? Find them anyways. So the foci are located along the major axis, so you're going to be adding and subtracting to the k value on a vertical one. So h, comma, k plus and minus c this time. So that would be 1, comma, 5 plus and minus. Now normally this is a funky irrational number, but not this time. So with that being said, I would like you to go ahead and tell me the 2 ordered pairs. So they're at 1, comma 1 and 1, comma 9, which is exactly where I plotted them.
How did you find out before you did the math?
The foci? So the c value is the distance from the center along the major axis. So I just counted up and down 4.
So the C value is basically the foci?
It's the distance from the center to either of the foci. Yep. One goes in one direction, one goes in the other.
And it's always whichever way is along the...
It's along on the major axis only. Yep, good question. It's the tape from our demonstration yesterday. Okay. All right. So that was beautiful. Can't wait to do all that homework. All right. Can you look at some atypical problems with me next? We're going to do these out of order. We're going to do 3, 4, and 5, but I'm going to do number 4 first because it's easier. Okay? So they're going to give you some like background clues. They're going to give you information, and then you're supposed to figure out like what do you have, what do you need, what formula am I looking at. You also have to decide whether you are a picture drawer or a formula person, and it could be a combination. Now, knowing me, you can guess that I am a picture drawer. They're not good, but I need it to visualize what's going on. So for me, what I do is I plot what they gave me. And it's a game of vocab. So when I say these are the vertices, they're telling me that those are along the major axis. That's the longer axis. So, sure. That's not at all what I wanted to draw, by the way. All right, so you have vertices at -2, -4. So I'm going to pretend that's like right here. And then -2, 8. So with this being called the major axis, what kind of an ellipse are we looking at here, guys? A vertical ellipse. So what I'm going to do is I'm going to write down the formula for a vertical ellipse. And as I find things, I'm just going to be plugging them in. So a vertical ellipse off your formula card, I believe it starts with y minus k squared over a squared plus x minus h squared over b squared equals 1. I actually think we have some information here. So if this is the major axis, you guys could find the center just by doing some midpoint or visualization even. You don't have to do the formula. So clearly it's going to be an x value of -2. Can you find the middle of -4 and 8? I think you can. Don't you just add them up and divide by 2? So -4 plus 8, divide that by 2. I think you get 2. So this ordered pair is at -2, 2. What y'all just found for me is your h and your k. Now be careful. They have to go in the right spot. This is k. This is h. So this is y minus 2 squared. And this would be x plus 2 because of the minus minus. Now, I would argue you also know A. A is the distance from the center to one of the edges. Okay? So this right here was -2, 8, one of the vertices. And this was -2, 2. So what was the distance here? 6. Now, if you aren't happy with that visualization technique, you can be a formula baby. All right, here's how the formula works. I look at my formula for a vertical ellipse because I figured out that much. I have a vertical ellipse. You can take either one of the vertices. I choose to take the more positive one, the one that would have been from the something plus a part of the formula, so I'm going to take this guy. This ordered pair was found by us following this formula. H, k plus a. Now think about that, guys. This number 8 was found by taking k plus a. So I could have set up an equation that said 8 equals, you already knew k, so 2 plus a. And then if you solve the equation, you get a equals 6. Now, what was easier to you? For me, looking at the picture was easier. Now, the only drawback to the picture is what if it's really funky? What if it's like the square root of 7? Like, then I'm not so good at visualizing. So I do have a fallback. I can use the formula if I need to, but I think visual approach is much better. So y'all just found a is 6, so we can plug it in here. That means this denominator is a 36. And all I need from you guys is something about the minor axis, which they tell you. Now be careful here. The length of the minor axis is 10. So that means when they draw the rest of the ellipse, the length from here to here is 10, but the value of b is not the entire length of the axes, it's just from the middle out. So if the whole minor axis is 10, that means b is half of that, it's 5. So that means down here is a 25. And we be done! Ooh, that was beautiful, right? That was it. So some takeaways I have from that experience. I feel like drawing the picture is the way to go. In almost all cases. At the very least, it helps you kind of get started so you know what formula you're looking at. What you're about to find out is if they don't tell you things about the major and minor axis, or vertices or covertices, and they do tell you something about the foci, that kind of extends your work to the next level. Anytime they include foci into your problem, it's a little harder. Because foci uses the value for c, which isn't even part of your formula. So that's an extra step of work we're going to have to get through. Like number 3. All right, so our lesson has been learned. We will be sketching this out. It's going to look awful, and I don't care. All right, so here we go. We've got an ellipse that has major axis vertices at -12, 6, which I'm going to pretend is right here. And then I'm going to pretend over here is 4, 6. Clearly not to scale. I don't care. So this is the major axis. And then the other clue it gives me is that we have foci at -10, 6, and at 2, 6. Okay. That's all very interesting. You know what they didn't tell me? The stinking center. But I think we can find it. Like, I can visualize it if I drew better, but I didn't. So the center is going to be located smack dab in the middle of either the foci or the endpoints. It doesn't matter because it's the same center. So clearly it's a height of 6, regardless of how far out it is. You got to tell me that one. So what's in the middle of either negative 10 and 2 or in the middle of negative 12 and 4? You're going to start rattling off numbers to me. Negative 4 was right. I was just going to try to write something down. All right, so this is like if you did negative 12 and 4. That's negative 8 over 2, so negative 4. Now, what kind of ellipse do we have? Horizontal or vertical? Horizontal. So, the horizontal ellipse is the one that starts with the x, and the a value, the major axis, is with the x. So, who else goes with the x? Some part of the circle, the center you just found. So the plus 4 in the factor, x plus 4, and then the y minus 6. All right, so we got our h and k put in. I would argue you actually know your a value if you do a little thinking. You can either measure from the center out, because you just found the center, or you can find the whole axis and cut it in half, but I need to know how large a is. So remember, y'all just found the center to be at negative 4, 6. So it's a distance of, I'm seeing 8 units. Negative 4 to negative 12 or negative 4 to 4. So A is 8. So down here, you're going to write 64. And this is where I get a little sad, because the other thing I need has to do with the minor axis. Do they give you any information about B or a minor axis? No. They tell me foci. Great. All right, well, foci is important to me because it's how I'm going to find the minor axis eventually, but the distance from the center to your focal point, either one of them, is a distance of c units. So from negative 4 to 10, how many units is that? 6 units, good. Not a part of my formula, though. So here's what we got to do. You've got 2 equations that relate a, b, and c together on your formula card. You've got like the square root one that we keep using to find c, but then right above that, I think you have this one, c squared equals a squared minus b squared, which is just unsquare rooted. So if you know c is 6, that means this is 36. You already found a squared to be 64. And this is going to work out beautifully, guys, because what I need to put down here in the formula is literally b squared. So if you can just figure out what b squared is, stop there. And I think you can. You're going to subtract 64 from both sides. You're going to get, what, 28? Oh, negative 28, excuse me, equals negative b squared. And then if you divide both sides by negative 1, you get b squared equals 28. Don't bother square rooting it, because I don't want b. I want b squared. This goes right here. Ta-da! So it's not awful. Like, it is one extra step. Like, you have to use the focal points to find c, which then you use that to find b. That's annoying. But can we all agree, like, a picture is worth it? Even a crappy Abruzzo picture. And frankly, when I'm doing this on a test, I do the best job I can do, which still is crappy, but that's okay. Let's try one more. Ugh, both sides. Okay. It's okay. We got this, guys. We got this. So, a picture. I've learned my lesson. I need a picture. This time, that's straight. Close enough. My foci are at negative 2, 1 and negative 2, 7. Foci are along the major axis, so that tells me my vertices, wherever they are, they're like here. We're going to have, you know, this is my baguette. Right? Looks like a baguette. All right. They do tell me oh, that's a nice clue. The length of the major axis. Y'all, that is the best clue I've had all day. That tells you something. How big is A?
5.
Good, it's 5. I also now know that I have a vertical ellipse. So when I go to plug some stuff into the formula, I'm going to be using the vertical formula, where the y would come with the major axis, which y'all just found was a 5 for A, so that means A squared is 25. You know what I haven't found, though? I haven't found the center or B. The center seems important. Daniel did a quick little midpoint formula thing. He says it's at -2, 4. 1 plus 7 is 8. Cut in half is 4. Very good. Now, put the H and K in the right spot. Who goes with the Y? This is H. This is K. So Y gets the Y value from the center. So Y minus 4 squared. And then X minus -2 would be X plus 2 squared. And then I'm kind of sad because they did not tell me anything else useful other than the foci. So the distance from the center to either one of the focal points. Now it looks like a football. Either one of the focal points is a distance of C. So if you could figure that out for me, I'd be very happy. 3 units. Very good. Not a part of my formula, though. So over here, C is 3. Cool beans. I'm going to use that neat little formula that relates A and B and C. Because I do have A. So C squared would be a 9. A squared would be a 25. I don't know B squared, that's what I'm trying to find. So a little subtraction and division, and you end up with B squared equals 16. Don't bother finding B, because I don't want it. I just want 16 right there. And then equals 1. Yeah, they get better. Did you notice what I didn't even bother doing on that question, though? Did I ever once pop out a formula for, like, foci? And no. I went straight off the picture on that one, which I think is really the way to go. However, for my friends out there who are like, no, I love formulas, you would choose either one of the foci, whichever one makes you happy. I like the larger one, the more positive one, so I would go with this one. And I would look up the formula for foci on a vertical ellipse, which would be h, comma, k plus c, if you're going to the bigger one. So then I would set up 7 is k plus c, so 7 is k4 plus c, and then I'd figure out that c is 3, which is the same thing we already found. But if you have numbers that aren't so pretty, or fractions or decimals or something that you're not happy to work with, maybe a formula is the right way to go. All right. One more topic. It's super easy, guys. We'll talk more about this later once we learn the other conics, but eccentricity is the ratio of the distance between the foci versus the distance between the vertices. So if you think about, us with the tape over here, you had your tape locked down. The distance between the foci would be this distance. Oops, this distance, right? And then the distance between the vertices would be this distance. So we're going to be having a larger denominator, right? So whatever this number is for ellipses, it should be coming out to a number between, here we go, between 0 and 1 every time we do an eccentricity question for an ellipse. The closer you get to 0, the more circular your ellipse, okay? Because if your foci, if your tape pieces got brought together, what shape are you making now? A circle, because you'll have a center point. So the closer and closer your foci become, the more circular you get. But the further out they get, and the closer they get to the vertices, yes, and what ends up happening, and you're not going to believe me right now, but I got to show you animation next week, it ends up being a parabola once you tip over to a 1. That's a weird thought. Okay. So, I know, Daniel's got thinking face on right now. Don't worry about it till next week, okay? So, to find eccentricity today, all you're going to do is, oh, here's a nice visual for it. This is going more circular, but it doesn't show you the parabola one. The parabola one's kind of hard to figure out unless you have the cone animation coming up. To find eccentricity, all you guys need to do is take C and divide it by A. So I'm sure that's on your formula card somewhere, but you might want to write it somewhere big and proud on your notes. So that last question we just did, at the end of it, I could have been like, hey guys, find eccentricity. And you'd be like, okay, Bruzo, so the C value on this question was 3. And you divide it by the length of A, which we found was a 5. And then typically we want these written as decimals, so they're a little easier to compare to each other. So 0.6 would be the eccentricity of this particular ellipse, which if I graphed it, that would look like a nice solid Easter egg. Not quite circular because it's branching in the other direction. More baguette-y than Easter egg, I suppose. Okay? That's kind of it. We'll revisit the concept of eccentricity later. So you have now another assignment to do, officially. You actually have 2 assignments for ellipses. You got day 1 ellipse and day 2 ellipse. You are working on them, and you're going to ask me questions tomorrow. So tomorrow is a question/work day. And then on Friday, you guys are working on your review. You can either choose to play the video, or you can just work on your review. Your test is going to be Monday. I am not here on Friday for you guys. I'm watching my baby's speech.